Hello everyone and welcome to another screencast. Today we are going to be continuing to abuse GitHub Copilot, and this is a Division 3 on Codeforces. I'll try to explain my solutions as I go along, but that's about it. Let's begin. Polycarp had an array A of 3 positive integers. He wrote out the sum of all non-empty subsequences of this array, sorted them in increasing order, and got an array B of 7 integers. For example, then Polycarp wrote out all the subsequences, and after sorting he got this. Unfortunately, he lost array A. He only has array B left. Help him to restore the array A. Okay, so we have 7 numbers and what we want is we want to restore. Okay, so how can we do it immediately? So the biggest number has to be the sum of all the 3 numbers. Okay, so this is one thing. The sum of all 3 numbers has to be this. 1 2 3 6. Okay, so the smallest number has to be one of the numbers, and then so would be the second smallest, and then the third number would be the largest minus these two. Reason being, the third number could be bigger, right? Is that true? I mean, looks true to me. 1 2 2, yes. So we have an array of 7 integers. Then we take that as input. C would be a dot back minus the first 2 numbers, and then I'm just gonna print first number, second number, and C. Okay, so GitHub Copilot didn't really help this time. Well, next time. Okay, 1 4 3 1 3 4. I mean, do we need sorted order? Okay, accepted. Cool. Problem B. Polycarp has come up with a new game to play with you. He calls it a missing bigram or bigram. Okay. A bigram. No, it is bigram, I think. A bigram. I'm gonna call it bigram. A bigram of a word is a sequence of 2 adjacent letters in it. For example, word ABB contains bigram. ABBBBA. Okay. The game goes as follows. First, Polycarp comes up with a word consisting only of letters A and B. Then he writes down all its bigrams on a whiteboard in the same order as they appear. After that, he wipes one of them off the whiteboard. Finally, he invites you to guess what the word he has come up with was. Your goal is to find any word such that it is possible to write down all its bigram and remove one of them such that the resulting sequence is that. So we can generate any string. Okay, so we have bigrams. So how this goes is, this is obviously the first character. Then this is the second character. Now, since this also takes the second character, right? Now, since they are similar, so since they are same, that means I can just append them. Otherwise, if this was A, then that means something was removed from here only. So we have to keep trying to generate the string from this side, from that side, and whenever the right and the left do not match, okay, then that means something was removed from there. But what if we are able to form the entire array? Then that means is that I can just add A here or B or whatever, depending on what the last number here was, I mean character. Okay, so we are given n, and then we are given n minus 2 bigrams. Okay, integer n, and then okay, vector. So yes, n is greater than equal to 3. Okay, and they also say that the answer always exists, so we don't have to worry about any other edge case. Now I will go for every s in A. Okay, first of all, I can just do this. I can just start from here, and now I'm gonna loop like this for integer 1, and a dot size I plus plus if a dot front is not equals to, first of all let's take the equals case. So if it is a continuation, then what we do is answer plus is equals to a I1, the second character. Otherwise what we do is we can just add to our answer a I. So reason being, let's say it was like this, right? We had a, then we have ab, and then we have ba. As you can see, uh, if let's say if this was removed, then I generated the string till here, and then I see a and b do not match. So what do I put here? Right, I can so what I can do is I can just assume there was bb here, and I'll just put b here, and then b here again. No, sorry. So then what I can assume is since this was a was here and b was here, so I just put b from here and then a from here, so it turns out to be equals to this only. So I can just do this, and what is the problem here? Okay, and then let's also do have a flag false, and I don't usually use this word, but okay, if you say so, Copilot. So if flag, what we can do is we can just do answer plus equals to this. That's right. So what happened this time? Actually, I can just add anything. So what's happening here is, if let's say the string was just like this, so we had 3 of these, 1 2 3, right? Yes. And then what happened was let's say this was removed, so we generated the string up to here. Now what do we print here? Then the last character can be anything. So okay, let's just test it right here. Okay, wrong answer on test 1. A B. Okay, we have to do this, and then this is the character, right? What is this? Good enough. Okay, is this correct? Okay, I messed up somewhere. So I say no, not ad blocker. So I say it is AB. So I can just put no, I think this was right. So I just said it's AB, and then I go and check that that was equal. If that was equal, then I can add to this. Sorry, if not flag. If not flag. Okay. Otherwise, what I do is, it was like AB, AB. So these are not equal. So what I'm assuming is something like this happens. So I get AB, AB, which is the same. Okay. Let's try again. Okay, accepted. Good. Took way too long to get this done. And Codeforces is not performing well today. Okay, problem C. You are given an array A consisting of n positive integers. You have to choose an integer D and paint all elements into two colors. All elements which are divisible by D will be painted red and all other will be blue. The coloring is called beautiful if there are no pairs of adjacent elements with the same color in the array. You have to find any value of D which yields a beautiful coloring or report that it is impossible. Okay. So we have an array. And what we have to do is we want to choose some number such that that number divides every alternate number, right? Because we want no two adjacent. So if this is the array, we don't want it to be like red red or blue blue. We want one to be divisible, one to not be, one to be, one to not be. And what will divide this and everything? The GCD. But we also have to make sure it doesn't divide this and this. Okay. And print 0 if okay, so I need to check GCD. If GCD cannot do it, that is let's take this array. Okay, we have A1, A2, A3, A4, A5, A6. First of all, I'll take GCD of this and this, and if the GCD divides any of this, okay, then that means any number which can divide all of them will have to be a factor of GCD will also divide them. So not possible. Then I will try the GCD of these and check the same thing. So if I cannot do in both cases, then too bad. Answer is 0. Okay, so let's take in no, I just want to do this. Okay, so let's make another function which will take in the array, and let's get this and let's get the GCD A0. Actually, let's give it some parity, and based on the parity we will do. So first of all, we will give it parity 0 and then parity 1. So now for integer I equals to 0, I is less than n, I plus plus, I can just do I equals to parity, GCD is equals to GCD, and then let's check for integer I is equals to parity XOR 1. So if it is 0, we'll start from 1. If it is 1, we'll start from 0, and we'll do the loop. And yeah, if GCD can divide, we'll return false. Otherwise, we'll return true. Good one, Copilot. Good one. Now we'll see bool this. Let's actually return two things. We'll return a boolean and the GCD. So in this case, we are returning 0, and in this case, we are returning the GCD. Good one. So we're gonna have can and answer. It is equals to that. Oh, sorry, it's not bool, it is auto. This is destructuring in C++. Now, if we cannot do it, okay, if we cannot do it, then I will do that again. Auto. Let's do this. Yeah, and then I'll just print the answer. Let's try. So Copilot assisted a lot in this one, and it didn't work. Okay, what is the problem? So the parity, we start from the parity. Oh, plus equals to 2. 1 3, so it's telling me 2. So what is the initial answer? Print can and answer. So I can do it. Okay. For parity, this is wrong. Okay, I need to check divisibility. So it says cannot. So if not can. Oh, is it redefining them? Is it redefining them? I don't know how to do that. Okay, whatever. Yep. Okay, I don't know how to destructure when variable is already declared. That is something I'm gonna need to check. Wait, this was 2 hours 15-minute contest. Okay. Alright. Let's do problem D now. You're given an array A of n integers and another integer k such that twice of k is less than equals to n. You have to perform exactly k operations with this array. Okay, and so k is less than equals to n by 2. In one operation, you have to choose two elements of the array. Let them be ai and aj. They can be equal or different, but their positions in the array must not be the same. Remove them from the array and add ai by aj to your score, where this is the normal flow division. Initially your score is 0. After you perform exactly k operations, you add all the remaining elements of the array to the score. Calculate the minimum possible score you can get. Okay, so we add the remaining elements, right? So we are gonna leave the smallest elements. What we are gonna do is we are just gonna sort the array. So let's say we have the sorted version here, and we can choose k pairs, right? So we'll choose pairs like this. For first pair we'll choose these two, and such that this is I and this is J. So this would be 0 because floor division. I mean, this could be 0 or 1. What if they are equal? Okay, first of all, let's say they are not equal. Then this would give us 0. So let's say k was 2, we took these two, and then minimum score would be this. However, let's say these two are equal, and this is somewhat less. Okay, so let's say this is a5 minus 1, and then there are two a5. If I choose these two, this would give me 1. And if I then do the sum, answer would be a5. If however I choose these two, then they would give me 0 and the answer would still be a5. However, if it was minus 2, then choosing these two would give me a5, but choosing these two would give me a5 minus 1. So this is optimal in all cases. So let's just do this. Integer n, we take in an array and then we sort it, and then what we do is we go, let's sort it, and then let's just reverse it, whatever. And then I have answer. Okay, for integer I equals to, okay, I'm also gonna store I, which is this. I also have k, right? Yes, good. So while I decrease this, what I do is answer plus equals to ai minus 1 divided by ai, and then I minus equals to 2, and then while I right, so for 1 2 3 4 5 I do them, I go here, and then I have to start from here, right? So while I answer plus equals to ai, and then I minus minus, this should work, but I'm just gonna have this check, whatever, and then let's print answer. Wait, and we got wrong answer. We did sort it. Okay, so what are we removing here? We have 3, so we remove 2 and 3. Okay, this is the edge case here. The problem occurs with 1. Thank you, samples. So the problem is that we have 3, right? So the thing is that we can do 2 by 3 once, right? But then what happens is we do 1 by 1, we still get 1. We do 1 by 1, we still get 1. So we get 2 and then 3. However, what we can do is we can make this pair and this pair, so both of them get 0, and then we have just one pair of ones, which is like that. Okay, so do I prioritize 1 or do I not? Is there a less messy way to do this? 4 of these, and then this. That's the first sample, right? 3, 4, so 5 of these. So making a pair of these, this and this gives me 1, this gives me 1, this gives me 0. So -5, -1, -1. However, if I, so -7, okay. However, if I do 1, 2, 3, 4, 5, 2, 3, and then I make pair of these two and these two, so they give me -3, -4, and then these two gives me -1. So uh, I have something in my mind, but I'm not sure if that's correct. How to do for 1? I want to come up with an algorithm which does it neatly while considering 1. 3, 4, 5. Another reason I'm trying to get with a neat algorithm is because, let's say I try to cover the edge case of 1, but I miss something in that. I'll get an FST worst case. So that is bad. Hmm. Or maybe I just have to treat it specially. So I have some ones and some non ones, okay. So I'm gonna call them 2. Now that's right. See, if I have only 3 of them, right? If I have only 3 of them, then this is optimal. This is optimal because this gives me -6. And if I were to break a pair, let's say with this, and do this, this will give me this gave me -4, 8, 12. Now this will give me -4, 8, 9. Sorry, not 9, 11. But anyways, that's bad. Now the thing is, oh wait, this still gives me 1, 2, 3, and 4, 5, 6, 7, and this gives me 1, 2, 3, 4, 5, 6, 7. Hmm. So what I propose is that I keep making pairs, and if I reach 1, okay, if I reach 1, then that means that this pair I'm making, okay, that this pair I'm making, what I can do instead is I can break a pair from before and make one here and make one here. So I can do this, and instead of adding 1 to the answer, I add 0. But okay, now this time I had 4. So 1 2 wait 4 8 12. No, 1 2 3 4 4 is the answer. If I were doing that, 1 2 3 4 5. Okay, it seems good. Now the only thing I have to keep track is that I cannot break more previous bonds than I have made. So let's keep a track of non-ones. And so if AI is not this, then non-one plus plus. Otherwise what I can do is answer minus minus, because I know for sure it would be 1, because AI is always greater than equal to 1. Else if non-1, then answer minus minus and non-1 minus minus. Okay, let's try this, and this passes. Okay, that's what I was talking about, that I definitely missed some edge case, and maybe this is not the edge case I'm thinking about. Maybe wait a minute, I had like this 7 4 1 1. uh, uh that's 5 7 10. Okay. mm. How many submissions are there? Quite a lot. Am I missing something? Wait, do I gotta do this the same thing? With this? Oh, oh. So let's say I had to make 2. I make them, and this gives me 0, this gives me 1, and then this gives me 4, so 5. However, if I make this, they both give me 0. Okay. However, if it was like this, However, if it was like this, then wait, I can make, wait, this can be an n square. Oh, I didn't notice. Hmm, this can be n square. So what is a good n square here? Hmm. Okay, how can I do it nicely? So if I have 5, now here I wanted to take 5 and 2 and then 4 and 2. Right, 4 and 2. Got it. So my approach of eliminating adjacent ones was a little bit wrong. So let's do like this. If I have k3, right, I'll take this one and I'll see which one can this eliminate. So from here to here, then I'll take this one, which one can this eliminate, then which one can this eliminate. This is good, I think. What if they're all 2? Then this does eliminate. Okay, we have to do it like that. Uh, so for integer I is equals to n minus k, I think. Right? Yes, I equals to n minus k. For integer j is equals to 0. Uh, okay, so do I even gotta do it like that? Okay, I have a better way. N minus 1, n minus k, I minus minus for j equals to minus k minus 1 greater than equals to 0. Wait, do I even gotta do it like that? Answer plus is equals to a I minus k divided by ai, and then for integer I equals to 0. and then AI equals to A. Okay. And then okay, I'm an idiot. I'm an idiot. Copilot didn't help me either, in my defense. So huh. So I'm an actual idiot. We have something like this, right? We just, if k is 2, just make pairs like this. It is always optimal. How can I be so stupid to not realize this? Right, that's right. Okay, let's continue. But before that, I gotta stay hydrated. So I'm gonna drink water. Alright, so problem E, n towns are arranged in a circle sequentially. The towns are numbered 1 to n in clockwise order. In the ith town, there lives a singer with, what the hell this mean? Okay, so skill set. So with a repertoire, whatever, with a R of AI minutes for each 1 to n, each singer visited all the n towns in clockwise order, starting with the town he lives in, and gave exactly one concert in each town. In addition, in each town, the ith singer got inspired and came up with a song that lasts AI minute. Okay, the song was added to his R so that he could perform it in the rest of the cities. Hence, the ith singer in the I hence the ith singer, the concert in the ith town will last AI minutes. In the I plus 1 town, it will last 2 AI minutes. In I plus k mod n plus 1 town, the duration of the concert will be k plus 2 times. Okay, so after singing at every town, the whatever is whatever that is increases by AI minutes. Okay, in the town, hmm, I didn't understand. So in that town there lives a singer with R of AI minutes. Each singer visited all in towns in clockwise order, starting with the town he lives in, and gave exactly one concert. In addition, in each town, the art singer got inspired and came up with a song that lasts AI minutes. The song was added to his showcase so that he could perform it in the rest of the cities. Hence, the art singer, the concert in the art town will last AI minutes. In the I plus 1, it will last 2 AI minutes. In I plus k mod n plus 1, it will last. Okay, so plus k, yeah, k plus 2. Good, good. In the town, plus AI, and in the town, hmm, what does last mean? What does the last line mean? In the this town, the duration of the concept will be k plus 2 times AI. In the town, I plus n minus 2 plus mod n. Okay, why do they write negative sign here? It became so confusing. You're given an array of b integer numbers where bi is the total duration of the concerts in the ith town. Reconstruct any correct sequence of positive integers a, or say that it is impossible. So we have three test cases, then the test cases follow. Each test case consists of two lines. The first line contains an integer n, so 1e4, the cities, and then the total duration played. we have to, okay, this is a constructive problem and I do not like it, but we'll play. I will do it. Open board. For each test case, print the answer as follows. If no suitable, no, otherwise yes, and then AI. Okay, so we have this circle, and then we have A1, A2, A3, A4, A5, and then A1 again. A person, let's say A1, starts here, does performance of A1. Let's change color. Performance of A1 here, 2A1, 3A1. So NA1, right? Then the person starts here and does A2, 2A2, and then n minus 1 A2, NA2, and then the third person starts here. Okay, so what you can see here is that, okay, let's change color again. Oh, oops, where's my mouse? We can see is that NA, so NA1 plus n minus 1 A2 plus AN is equals to BN. And then similarly, n minus 1 A1 plus n A2, right, no, plus n minus 2 A2 plus n minus 3A3, and so on up to what? So we go to AN minus 1 plus NAN, that is this. As you can see, there are, and we'll have n equations like this. So we have n equations, and in each equation there are n variables. So we just need to find, and everything has some coefficient. What we have to do is we just need to find a valid solution to this. Okay, how do I solve this? I know for a fact that if I want to solve a 3 by 3, I use some determinants like this, right? And I get all the stuff here, all the coefficients. But here, as you can see, the coefficients are n square. So that is not a solution. How can I get? So AI has to be less than or equals to 1. What happens when we add all of them? When we add all of them, I obviously get 1 plus 2 plus n times ai for every I is equals to sigma for all I pi. So that's another thing. Okay, how do I generate a solution for this? Do I have to stop looking too mathematically at it? Hmm. Well, let's look at this. We have 12, 16, and 14. 313. Hmm. Everything affects everything. Okay, let's have a look at when it will be impossible. When will it be impossible to generate this? Okay, whatever b1 is. Okay, whatever b1 is. What is b2? What is b2? Sorry, this was bn. Okay, so whatever this b1 is, and then whatever this b2 is, what is the difference between them? The difference between them is a difference of ai, then okay, as we know, everything increases by their ai, and every musician, except so if any musician between any two concerts increases his potential or whatever by ai, except when he returns back to except when we are looking back at his origin, in which case it is minus of an ai. So I know that b2 minus b1 is equals to a1 plus a2 plus up to an, and then remove a2 from here, and what we do is minus n times a1 a2 minus n minus 1 times a2, that is equals to b2 minus b1. And then when if we add all of them, no, what will happen if I add all of them? I'll just get something similar again. So I have b2 minus b1. Okay, so the difference gives me oh, let's have a look at an and an minus 1. Sorry, bn and bn minus 1. So bn is na1 and minus 1a2 plus an, then bn minus 1 is n minus 1 a1 plus n minus 2 a2, and we keep doing this, and then plus n times an. This goes to an minus 1, and again their difference gives me the same thing. It gives me the same type of thing. One, two, three, four. Okay, n minus one of those. Okay, notice there will be n minus one of these, and what that means is this is also n minus one, so this is a3. That means I'll get n minus one times a3 in positive. So if I get n minus 1 a3 in positive and negative, and this happens for every term, this is equals to 0. So the sum of their differences has to be equals to 0. That's one condition. And if it is not, then I cannot do it, obviously. If it is, however, then I claim that everything can be 1 except one value which will be adjusted. I'm not sure if this is correct though. I mean, I'm just assuming, because how hard will it be? So let's say it is 1. This is 1. So this is 3 times 1 plus 2 times 1 plus x is equals to 14. So 5, x is equals to 9. Okay, this doesn't work out. I also have to construct it. This is such a pain. How am I gonna construct it? There's some progress here, that the difference of all these things has to be 0. As you can see, this is 4, this is negative 2, and then this is also negative 2, so that's 0. We can check here as well. What is this? 81 minus 70, sorry, 75 minus 81 minus 6, 0, 5, 6, plus 13, minus 6. Wait, what? Let me check. Is my condition even right? Oh. And so yeah, this is right. Uh, 1 minus 2 is minus 1. 2 minus 3 is again minus 1. Then 3 minus 1 is 2. Okay. So 1 to 3 is not possible. Hmm. Why is this so tough? But there are 261 submissions. Hmm. Maybe it is not tough. Maybe I'm overthinking. Uh, very much feels like now I'm overthinking. So, what is this? Huh? Oh, I got it. So if I sum all of them, right, if I sum all of them, what will happen is that I will get n plus 1 by 2 ai for all I is equals to sigma I bi, right? So this way I can get sigma ai. Now here in this equation, this is equals to sigma ai minus n ai is equals to bi. So this was a2, right? Yeah, this was a2 is equals to bi minus 1. So this way we can get everything. Okay, good enough, good enough. So what do we have here? Integer n c in a. Okay, now let's get the sum. So I'm gonna say sum of b. I'm gonna call it b, and I'm also gonna have a. So wait, what am I doing? Accumulate all b. Let's do this. Bit may overflow. Wait, what? So I have the sum of the b. Now I'll go for integer I equals to 0 and just plus ai. So first of all, let's get the difference. That is bi minus b I minus 1 plus n modulo n. Good enough. And then ai is equals to difference. Okay, so it's gonna be, sorry, so this is ps. Now as, okay, multiplied by is equals to 2 there. So divisor is equals to n times n plus 1. If this happens, if it doesn't divide, I'll just print no. Otherwise a sum is equals to this, and then a sum minus difference, and then I just print a. Okay, this was an easy problem, not really difficult. I just happened to go on the wrong path. Now if ai, I also have to divide it by n, right? Otherwise, right, this is, yeah, this is that. So let's run all. Yes. Now if a sum is less than equals to is less than n, then again, okay, this was a good question. Nice one. I mean, I took forever like an idiot, but it was a good one. And wrong answer. Okay, so I have bn and an. I accumulate all of them, and that is equals to n plus 1 by 2. So bs multiplied by this, n plus 1 if this happens. Otherwise, yes, if as is less than n, obviously that. Now okay, diff is equals to bi. If I, then diff minus equals to this. Otherwise, right, right. So b1, so b1 minus bn, n minus 1 a1, and then everything else is just there, and this increases by 1. So and then what I do is I add to that, I get minus n a. I'm also gonna wanna check that AI is something, right? So we get the difference, and then AI. Yeah. Huh? I have long. Hmm. So n plus 1 by 2 AI is equals to bi. So I just multiply it. I mean sigma bi. The divisor is that if this happens, so get the difference. AI is equals to, so as you can see, a1 minus that. So a2, wait a minute, so a2 plus a3 plus an minus n minus 1 of a1, and then if I add a1 here, I can remove this, then I have this value, then I have this value. So as minus difference, if there is a modulo, this just is not possible, but okay. I don't get what I'm doing wrong here. So there's some is that, so 10 4. Okay, I am using 0 LL. ES means difference. What is wrong here? So either it doesn't divide, it is less than equals to 0, or it is greater than that. Uh, Please work. Okay, good. I was getting negative divisible. That's why. Okay, problem F. You're given two positive integers x and y. You can perform the following operations with x. Following operation with x. Write it in its binary form without leading zeros. Add 0 or 1 to the right of it. Reverse the binary form and turn it into a decimal number, which is assigned as the new value of x. So I can either multiply it by 2 or no. So the binary, whatever that is, so whatever the binary is, right? If I add 0 to it, right, I'm essentially just reversing its binary representation, because this when will it go here, it will be meaningless. However, uh, if I add 1, here, then to the decimal representation. Okay, your task is to find out whether x can be turned into a y after a certain number of operations. Okay, so how can we do this? I have to do this operation as many times I want and eventually reach there. So let's say we have some x. This will take me to x1 and x2. One of them is reversed position and one of them is whatever. Then this can take me to two positions. This can take me to two positions. Then this can take me to two positions. Two positions. Now what I say is that every time so what I say is, using DP I can cover all the states. Using DP I can cover all the states. Now this tree obviously goes way too big, but if I memorize this or just save the state, same thing, I'll be able to cover all of it. How? Well, let's start with 0. I can convert it to 0 or convert it to 1. Now as you can see, this this has already been processed or is already being processed, so I don't have to go there anymore. Now this can be converted to 1 again, right? Or this can be converted to 11. This is already being processed, so I can stop. Okay, whatever. So my idea being that reversing introduces one new thing, okay, one new number, and so one is reversing and one is adding 1 at the MSB. So that introduces one new number, and adding 1 at the MSB also introduces one new number. But here is the thing, this also increases the number of digits. So this cannot go on for way too long, and this, so I don't have much of a proof though, but I just think it will work because of this, because this very quickly exceeds 1e18. Just doing this operation very quickly exceeds 1e18, and we cannot keep doing this on used numbers. So that is why I say that. So let's take x and y, and okay, binary reverse representation of a number this is good. Wait, function to reverse bits of a number. Oh great, I can just use this. Yeah, okay, didn't even need to go there. Okay, I'm gonna auto generated by program. Okay, the next thing I'm gonna do is, wait, let me take a note. Okay, so we have this, and now the next thing I'm gonna do is, I'm gonna store this. I'm gonna say dp. So dp let's just use global variables here because I'm a good programmer. So I also have sort 2, and what this is, it will take a number and do whatever. Oh boy, what is this? And then I'll call sort2 with x, and then I'll say if dp y, then see what it is. Wait, do I even need a map, or I can just use a set? Yeah, so if dp.count y, print yes, otherwise print no. So now, first of all, then I'll just return. Otherwise I'll dp.insert x, and then if x is equals to y, I'll return again, or dp.count y. So the next thing, yeah, and then I'm just gonna solve for nx. Now x multiplied by equals to 2 plus 1, sorry, x is equals to x multiplied by 2 plus 1, and x is equals to reverse bits, and then I'm gonna say this. Let's see what goes. Okay, another thing, 18, I'm gonna return if dp.count x or y, if if x is equals to y, and x solve to, okay, this should work if the states do not explode. I heavily doubt the states would explode. The samples are very small. Okay, no, one of them is very big. Actually, we cannot actually know how big it goes like this, but okay. I'm just gonna call it cx current x. Cx okay. How far do I gotta go? So how is fourth? Let me just print for auto x and dp. It will give me another shadow warning. Print p. The reverse bit is rotation. Worthless. Uh, hmm. Let's remove unsigned. I'll deal with the unsigned later. Let's move this. One. No, what I'm saying. And what is the problem? And oh, is their code not even tested? Ah, I'll do it myself. Rep. I'm doing it in the lamest way possible. In that way. Okay. Yes. But I'm gonna need this. So I have the representation in reverse. Okay. Now I'll just trust it. Hmm. Hmm. Okay, let me test something. Print reverse bits of x, and also reverse bits of 2 times x plus 1. 34 and 69 for yeah, 17 and 81. Okay, I'm getting the correct answers. Now I'm gonna say solve 2, and here I'm gonna say current exact. Uh oh, okay. Welcome. And passed. Okay. My reverse bits function was the drawback. Okay. Can I full solve? The question lies, stands, whatever. Uh, well, oh boy. He took an hour and 38 minutes for this. Wait, no. I have to try this. Okay, I normally did it. What that means is, I thought this was the last question. I thought if he took this much time for the last question, I'm done. I'm not solving it. He probably started late. As you can see, he's starting from late. Okay, reverse. You're given two positive integers x and y. You can perform the following operation with x. Okay, no, I did it. I just did this problem. Monocorp plays a computer game yet again. The game has a unique trading mechanics. To trade with a character, Monocorp has to choose one of the items he possesses and trade it for some item the other character possesses. Each item has an integer price. If Monocorp's chosen item has price x, then he can trade it for any item, exactly one item, with price not greater than x plus k. Monocorp initially has n items. The price of the I is AI. The character Monocorp is trading with has m items, and is bi. Monocorp can trade with his character as many times as he wants, each time exchanging one of his items with one of the other character's items according to the aforementioned constraints. Note that if gets some item during an exchange, he can trade it for another item since now the item belongs to him, and vice versa. If Monocorp trades one of his items for another item, he can get his item back by trading something for it. You have answer Q queries. Each consists of one integer, which is the value of k, and asks you to calculate the maximum possible total cost Monocarp can have after some sequence of trades, assuming that you can trade an item of cost x for an item. Okay, so k is not fixed. I have n, m, q queries, and then this. So, first of all, getting an item back. So, let's say these are sorted, okay? We don't have time to look in unsorted ways. So what I can do is I can trade, let's say this with so Monocorp can give his item to him, Okay, let's say b4 was greater than a5, so we do a trade. Okay, so we do a trade b4 a5, and then we can, let's say a4 is less than a5, so we can do another trade a5 a4. I'm considering to stop trying, and the reason is simple. Even Neil took half an hour. If Neil took half an hour, I ain't doing it in half an hour. And other people also have not done it. And if I stop now, I can upload right when the contest ends. So a lot of views. So I'm gonna have to stop.